In the previous lesson, we saw that the string class has some methods, and we looked at 2 lowercase and 2 uppercase, and we used those methods to remove the case sensitivity in a comparison of 2 strings. The string class has several different methods as well as some properties, and in this video we want to explore a few more of those that are particularly useful. The first one is a property called length, and length simply takes a string. In this case, XYZ is the string ActionScript rocks with an exclamation mark, and returns the number of characters. And if we were to count the number of characters starting with A and going to the exclamation mark and including the space, we would have 19. And the value of len, which is an integer type variable, could have made it a number type variable, would be 19. Another method is indexOf. And I can tell this is a method because of the parentheses, and it takes one argument or passes one parameter, in this case the letter n. And I specify that in quotes, so it's a literal string, and it's going to return the location of the first n that it finds in the string XYZ. And that first n is here in the word ActionScript, and it returns a 5. That's the location of it. Now you're thinking, wait a minute, n is the 6th character. Why does it return 5? And the reason is we begin counting with 0. Anytime we're looking at an index number, indexes begin counting at 0. I think of locations always starting with 0. So if we were looking for a capital A, it would be 0. In this case, the n is index number 5. Another way to think of this is you can think of the character position and subtract 1, and that would give you the index number. Let's look at some more examples. I can look for more than one character. So in this next example, I'm looking for RIP, and it's going to search my substring and find the first location of RIP. And it's going to return where that begins. It begins at index number 8. So the value of LOC, this time declared as a number data type, would be 8. In the next example, we're looking for R, but I've got a second parameter here. It's a comma 10. So my parameters are separated by commas. So the second value is 10, and that tells it where to start looking. So I'm going to start looking here, and I'm looking for the first R. My first R is position number 13 overall in the string. That would be the value of LOC. The next example, looking for an uppercase A, that's going to be character 0, index number 0. And then I'm looking for a lowercase a. That does not exist in my phrase, and the value that's returned by indexOf, if it can't find it, is a -1. Now I might use that to my advantage if I want to search for a string and provide feedback to the user if it's not found. I might put in a condition such as if xyz.indexOf lowercase a equals a -1. I might set feedback .text to string not found. Now if I want to make this case insensitive, we've already seen that I can use 2 lowercase or 2 uppercase. So if I change XYZ to all lowercase and search for lowercase a, now it's going to find it at character 0. But if I set it all to lowercase and I'm still looking for an uppercase a, it's no longer going to find it, and LOC becomes a -1. If I begin looking for an uppercase C starting at position number 5, having made XYZ all uppercase, it would find it at position number 7, or index 7. So here's a summary of the properties and the methods we've looked at thus far in this lesson. We've had length, which returns the number of characters, indexOf, which returns the location of a substring, and if it doesn't find it, it's a -1. And then we've already seen 2 lowercase and 2 uppercase that converts our string to all lowercase or all uppercase. Another method of the string class is the substring or substr method. Notice there are actually 2 of them here. There's substr and there's substring, and I'll explain the difference here in a minute. I tend to prefer the substr, which I usually refer to as substring as well, but there's a very fine difference between these 2. So I've got my string here of XYZ ActionScript rocks. What substr does, or substring does, is it extracts part of that string and returns it. In this case, I'm going to apply it into another string variable called ABC. So this substr6 is going to look at location 6, which is the letter S, and it's going to return 6 characters. So I'm going to get script, S-C-R-I-P-T, those 6 characters as part of my string ABC. The next example here is I've got 0, 3. So the first number is the location. That's going to be 0, index 0, that's the A, and return 3 characters, ACT. So ACT, with an uppercase A, would go into ABC. 10, 1 is the third example. The 10, index number 10 is going to be the letter P. You return 1 character, so all it is P goes into ABC. And then the fourth example here, I only have one number, and if there's just one parameter or one argument, it's going to be the location, in this case index 13, and it's going to extract everything to the end of the string. So ABC in this case would equal rocks with the exclamation mark. I'm not limited to using hard-coded numbers here. I might use variables. In this case, substr 0, len minus 1. Well, len was 19. So in essence is 0, 18, which is going to start at character 0, give me 18 characters, and it's going to be ActionScript rocks without the exclamation mark. Remember, there are 19 characters total. Or I might just want to extract the last character, in which case I'm going to extract len minus 1, and ABC would equal an exclamation mark. Now we also in ActionScript 3 have this substring method, which also takes 2 parameters, and here's the difference. This is the first one is still the location of the string I want to extract. So in this case, character 10, or index number 10, is going to be the P, and then the index of the last character I want to extract, exclusive. So 10, 12 is going to give me 10 and 11. It's not going to give me 12. So it's going to give me character 10 up until index number 12. PT is what would go into ABC. Well, let's look at how we might use this in some projects. In my first project here, I've got a text box, an input box. The user enters a name, first and last name. They're going to click this button called Extract Names, and it's going to place the first name and the last name in these 2 text boxes. And then I'm going to get a welcome message in this text box that's going to say something to the effect of, "Welcome, Thomas. We're happy to have a member of the Jefferson family." So we'll use these 2 values that we're extracting within the context of a larger concatenated string. Let me just run this. So I've got Thomas Jefferson in the Enter Name text box. I'm going to click Extract Names. I'm told the first name is Thomas, last name is Jefferson, and I get "Welcome, Thomas. We're happy to have a member of the Jefferson family." Now it doesn't really matter where that space is located. If I type in Abe Lincoln and press Extract Names, Abe is the first name, Lincoln's the second. "Welcome, Abe. We are happy to have you. We're happy to have a member of the Lincoln family." If I put my own name in here, Stephen is the first name, Hustedde is the last name, and I get "Welcome, Stephen. We're happy to have a member of the Hustedde family." So it doesn't matter where the space is located. We're going to use variables to figure out where that space is and use that in our strings for extraction. Let's look at the code. So first of all, I have a change event for my input text box, and all that does, it calls a method called clearOutput. So anytime I change the name, I'm going to clear my 3 output fields, setting them to null strings: first name, last name, and welcome text boxes. The text becomes quote, quote, or null. That'll clear out those text boxes. Then my extract button is calling a method called extract names, and here's where we're going to use our indexOf and our substring, or substr methods. So I first have a variable called LOC, which stands for location, and I'm simply going to find the location of the space, quote, space, quote, with the index of, and determine where that space is located. I'm going to store that in this variable lock. Then my first name, or my variable fn, is a string variable. It's going to extract that first name by extracting the substring, or substr, starting at character 0 and returning LOC number of characters. So if I had John Doe, my space would be index number 4, it's the 5th character. LOC would be 4, and I'm going to return 4 characters. So I'm going to take everything up to that space. My LN, or for last name, is a variable, type string. I'm going to do the same thing. I'm going to use substr to extract everything after the space. So I'm looking for the location +1. So in the case of John Doe, my LOC or lock variable is 4. I'm going to add 1 to it, 5, and starting with character index number 5 would be the last name Doe. I then simply output first name and last name, and I use those two values in a concatenated string for the welcome text, in which I have a little string of welcome. I'm going to concatenate the value of first name. Notice I put a space after the word welcome in the literal string, so these don't run together. Follow that with an exclamation mark, and then my second sentence, we are happy to have a member of the, and I've got a space after the. I'm going to concatenate LN for last name, and concatenate to that a space family period string, and that is my output for welcome_txt. Here's another example. Here I'm going to use the length property as well, and I've got a string here. This is called body text _txt. That's the name of my text box. It's an input text box, and by default I'm going to start with 2 sentences. Now's the time for all good men to come to their country, and the quick brown fox jumped over the lazy dog. I've got 2 more input text boxes. This one's called search_txt. This one's called replace_txt. And when I click the go button, I'm going to search for whatever text is in here. In this case, I'm going to start with fox. I want it to come find the word fox in this text box and replace it with the word elephant. Well, let's test this. So I'm going to click go. Go replaces fox with the word elephant. If I wanted to search for lazy, I can type in lazy, and I want to replace it with hungry. And we see that happen here. I might search for men and replace that with men and women. And now it's for all good men and women to come to their country. Or I might replace men and women with cats. And now is the time for all good cats to come to the aid of their country. The reset button simply resets my original text in the body text, and search and replace resets them to fox and elephant. Let's look at the code. So here's the reset function that simply is resetting body text, search, and replace text fields with my default. What we're really interested in is the go button, which is going to call on a click event search and replace. And here then is my search and replace method. I'm going to use 4 variables: search length and search index, which are both of type integer, and string 1 and string 2, which are both of type strings. Search length is going to be the length of the word I want to search for. Search index is going to be the location. And then string 1 is going to be everything in front of that word or phrase, and string 2 is everything after that word or phrase. And then I'll concatenate string 1 with my replace string and with my string 2, and that becomes the new body text. So I'm going to begin searching body text using indexOf, and I'm searching for whatever word we have in our search text box. If it finds that, if it's not a -1, so notice I'm using the not equals, then I'm going to go ahead and build my replacement string text with everything that comes in front of the word I'm searching for. So I'm going from 0 to the search index, just like we did earlier with the space in the name. String 2 is going to be everything after the location of my search, where my word is, and the length of it. So if fox is 3 letters long, I want to start 3 characters after where it found that word. And then finally, doing my concatenation, string 1, I'm going to concatenate to it my replacement text, which would be elephant if I'm going to replace fox with elephant, and everything that comes after the word fox, which is string 2. If it doesn't find the search, I'm going to call up a movie clip called not found and go to and stop on frame 2. And I'll show you what that does as I rerun this. So again, here's changing fox to elephant. And now if I wanted to search for fox again, I'm going to click go, and it says it's not found. Fox is no longer in my phrase. And so what this did, when it didn't find it, I got a -1. And in my program, I have a movie clip. Notice over here in the properties, I've clicked the little rotation point for my movie clip. The first frame of that movie clip has no information in it. Let me double click on it so we can see the movie clip. So I'm now looking at the movie clip. Everything else is grayed out. I can see in my cookie crumbs here, I'm looking at MC dialog not found. There's my first frame. There's nothing there other than I have an action that says stop. So it stops in that first frame. So in my code, when I'm calling to go to the second frame, that's where it goes. It brings up this dialog box. I have 2 buttons here, an OK button and a close button or an X button. And both of those call the same function. They both call hide me when the user clicks on them. And all it does, it goes back to and stops on frame 1 so that everything basically disappears. And I'm back to seeing that. Well, what if I wanted to search for multiple instances of the word fox in this code? I can do it within a loop. So here's the same example, but my starting code now has the word fox 3 times. So I have in here the quick brown fox jumped over the lazy dog, my fox is smarter than your platypus, and my fox likes to play chess. If I test this, I'm going to click go. And now it says the quick brown elephant jumped over the lazy dog. My elephant is smarter than your platypus. My elephant likes to play chess. Let's take a look at how I modified this code. And all I did was add a while loop. As long as search index does not equal -1, I'm going to replace the word with the search word with the replacement word. And then I'm going to search for the next occurrence. And so finally it will end up where it doesn't find the word again. This becomes a -1, and this loop stops executing.